Is there anyone who has got the answer for this question? Anyone? Okay. Fine then. So I'm going to ask you guys a few simple questions based on power cycles. Can you guys tell me what would be the last digit of 145 power 145? What would be the last digit of 145 power 145? Anyone? All these concepts we have already seen. 145 power 145. Very good, Tanuj, Balaji, Harivardhini. Very good, guys. Excellent. For those of you who do not remember this power cycle concept completely works on the last digits. For example, if the last digit of this particular number is 5, the base value's last digit is 5, then you don't have to worry about the power value at all. You don't have to worry about this value at all, because no matter what the power value is, the last digit is going to be 5. Similarly, if the last digit of the base value, let's say 236 power any number, you don't have to worry about what number it is. The last digit is going to be 6. Similarly, when any number that ends in 1 power any number, what will be the last digit, guys? It would be 1. Similarly, 3570. If a number ends with 0 and power 35, what will be the last digit, guys? It will definitely be 0. Correct? So if the last digit of the base values are 1, it would be 1. 5 would be 5. 6 remains 6. And 0 would remain 0. Clear? And for this particular question, I'm going to ask you guys a different question. Definitely 3570 power 35 is a very big number, correct? And it is going to end in 0. But can you guys tell me how many zeros will be there at the end? How many zeros will be there in the end? Come on, guys. How many zeros will be there in the end? Very good, Harivardhani. Excellent. You're right. It would be 35. How is that so? See, take any number of that sort. For example, okay. Okay, let us take this. Let's say 10 square would have 2 zeros. 30 cube will have 3 zeros in the end and some number in the front. I don't have to worry about that because my question is completely based on zeros. Similarly, this number power 35 will have 35 zeros in the end. Okay, fine guys, enough then. So we have discussed about 1, 5, 6 and 0. Now let's discuss about the other numbers. Let's say, for example, let's take 4, 9, for instance. Let's say if the question is 24 power 24, what will be the last digit, guys? What will be the last digit of 24 power 24? Any idea, people? Just look at the unit digit 4 and look at what is going to happen for the powers of the unit digit. Okay, I've got answers. Okay, few of you guys are telling me the answer is 4. Few of you are telling me the answer is 6. Okay, let's discuss that. Okay, very good, guys. Correct. Superb. Lokesh, Tanuj, Sham, Grazia, Giridharan. Superb. So, guys, listen here. Just look at the last digit 4. So, that is what is required. Look at 4 power 1. What would happen in 4 power 1? 4 power 1's value is 4. What is 4 square? 16. So, it ends in 6. What is 4 cube? 64. Again 4. So 4 power 4, again it ends in 6. So the logic is, if a number ends in 4, if the power value is odd, then the last digit is 4. See, 4 power 1, last digit is 4. 4 cube, last digit is 4. Similarly, 4 power even, the last digit is 6. So here the power value is 24, which is an even number. So my answer is 6. So if it is 4, the last digit is either 4 or 6. If the power value is odd, 4. If the power value is even, it is 6. People, excellent. Very good. Okay, moving on. We'll take a different number. For example, 689 power 793. What will be the last digit of this one? Very good. Grazia, Harivardhani, Shyam, Nitya Kalyani, and Deepthi. Awesome, guys. Because the last digit is 9. So if you look at 9, so 9 power 1, it ends in 9. 9 square, it is 81, so it is 1. 9 cube, it is 729, it would be 9. So 9 power 4, so I don't know the value of 9 power 4. You don't have to worry about that at all. So instead, what I would suggest is multiply 9 with this one. You get 81, 1. Multiply 9 with 1. 9 ones are 9. You get 9. Again, multiply 9 with this one, 81, 1. So this is how it is going to go on. Which means, again, if it is 9, if the power value is odd, then it is 9. If the power value is even, then the last digit is 1. Clear? So far, finding out the last digit of these numbers are easy. Correct? But what about the other numbers? For example, if you look at 12 power 120, okay, let's say 126. 12 power 126. This is the case. Let's see. Okay, I'm going to ask you guys this question. Let's see how many of you guys remember this. What would be the last digit of 12 power 126? No one remembers the method, huh? Very good, Gracia. Very good, Shyam. Super, guys. So, guys, listen here. Others, for those of you who do not remember, if you look at 2, let's look at what happens for 2's powers last digits. 2 power 1 would be 2. 2 square would be 4. 2 cube would be 8. And 2 power 4 would be 16. So 6. 2 power 5, 32. 2 power 6, 64. 2 power 7, 128. 2 power 8. It goes on like this. 256, 512. Okay, 1024. It goes on like this. So there is a pattern in which the numbers repeat. The pattern is 2486, 2486, 2486, 2486. So if it goes on like this, in which line would I have 2 power 126? So that's my question. How do I find that? Take the power value divided by 4. Why is it 4? Because there are 4 numbers in the cycle. Divided by 4, find out the remainder. Okay. If the remainder is 1, then the last digit is 2. If the remainder is 2, then the last digit is 4. If the remainder is 3, then the last digit is 8. If the remainder is 0, then the last digit is 6. Clear, people? Now, if I take 126, 126, if I divide it by 4, 126, I'm sorry, 126 upon dividing it by 4, can you guys tell me what is the remainder here? What is the remainder, guys? If I divide this number by 4, what is the remainder that I get? Very good, Gracia. It would be 2. Guys, remember, what is 4's divisibility rule? You just have to look at the last 2 digits. 26 by 4, what is the remainder? 24 is divisible, so 2 is the remainder. So what did I tell you? If the remainder is 2, then my last digit is 4. Clear, people? If it is 2, okay, so it would be either 2, 4, 8, or 6. If the remainder is 1, the remainder is 2, remainder 3, and remainder 0. Okay, so before we move on, I'm going to ask you guys a simple question from 2. 562 power 563. Can you guys tell me what is the last digit? What is the last digit here? Guys, think carefully. What are you supposed to do? Power value divided by 4. What is the remainder, guys? Power value divided by 4. What is the remainder? What is the power value? 563. If I divide it by 4, what is the remainder? Just look at the last 2 digits, 63. 63 upon dividing it by 4, what do you think would be the remainder? 60 is divisible, 64 is divisible, correct? 60 is divisible. If 60 is divisible, then the remainder is 3. Very good. If the remainder is 3, then what is the last digit, guys? The remainder is 3. What is the last digit then? Very good. Yes. The answer would be 8. Okay. Excellent. Similarly, can you guys tell me what is the cycle for 3? Check for 3 powers and tell me what is the cycle, or else what are the numbers which keep repeating in 3's powers. Okay, 3 power 1, it's 3. Very good, guys. Most of you guys have given me the correct answer. Very good. Harivardhani, Deepthi, Adavan, Nitya Kalyani, and Grazia. So 3 square, it is 9. 3 cube, 27, 7. 3 power 4, 81, 1. Again 243. So it goes on, continues. So 397. So the logic is again the same. Power value divided by 4, find out the remainder. Okay, for the corresponding remainders, these are the last digits. Okay, for example, 123 power 542. Can you guys tell me what is the last digit here? Very good, Sham, Grazia, and Harivardhani. Excellent, guys. Superb then. So take a power value, which is 542. If I divide it by 4, just look at the last two digits. That's what I've told you. 42 by 4. What is the remainder? Remainder is 2. If the remainder is 2, then the last digit is 9. That's all. So for 3, 9, 7, and 1. Similarly, what are the numbers that we have in the cycle for 7, guys? What is the cycle for 7? What is the cycle for 7? Excellent, Deepthi, Samson, Harivardhani, and Nitya Kalyani. Very good. And Grazia. Very good, guys. So it would be 7, 9, 3, and 1. And if you guys are wondering, sir, I don't know the value of 7 cube and all that. So you don't have to worry about that at all. Just multiply 7 with this one, 49. You get 9. Multiply 7 with this one, 7 9s are 63, 3. Multiply 7 with this one, 21, 1. Multiply 7 with this one, you get again 7. Clear? Super, guys. Now here's the question. Let's say the question is 567 power 567. Can you guys tell me what is the last digit? 567 power 567. Very good, Sham. Superb. Very good, Deepthi. Awesome, guys. So what would happen here? I will take the power value, which is 567. So I can just take the last two digits, 67. If I divide it by 4, 64 is divisible. So the remainder is 3. If the remainder is 3, then the last digit is also 3. That's all. Clear? Super, guys. Similarly, find out what would happen for 8. What is the cycle for 8? Very good, Harivardhani, Deepthi, and Gracia. See, it would be 8, 8 square, 64, 4, 8 cube, 512, 2. And what did I tell you? Even if you don't know the values of 8 powers, just multiply 8 with the first one, 64. 8 fours are 32, 2. 8 twos are 16, 6. 8 6 are 48, you'll again get the first value. So the pattern repeats. So what is the pattern? 8, 4, 2, 6. So the logic is again the same. Let's say, for example, 678 power 789. Can you guys tell me what is the last digit here? Power value divided by 4. Find out the remainder. Based on the remainder, you can find out the last digit. That's all. Very good, Deepthi. Very good, Sham. Super, guys. Excellent. So what are we supposed to do here? 89. Correct. So 89, if I divide it by 4. So why did I just take 89? Why not 789? Because that is the forced divisibility rule. Just take the last two digits. That's all. So 89 by 4. What is the remainder? 88 is divisible. So the remainder is 1. The remainder is 1, then my last digit is 8. Clear, people? Excellent. Now, out of all the single digit numbers that we have seen, 1, 2, 3, 4, 5, 6, 7, 8, 9, which ones are a bit tedious compared to the others? Which is bit tedious? For which numbers finding out the last digit is bit tedious compared to the other methods? Yeah, guys, did you all understand the question? What did I tell you? I asked you guys, for every single number like 1, 2, 3, 4, 5, they have individual methods to find out the last digits. Out of all these methods, which numbers had difficult process? Which are the difficult methods? Like for 1, there is no method at all. The answer is straight away 1. For 5, there is no method at all. The answer is straight away 5. But which numbers had difficult processes to find out the last digit? Very good, Nitya Kalyan. Yes. So it was 2, 3, 7, and 8, right? 2, 3, 7, and 8 had difficult processes. So this is a fun fact. 2, 3, 7, and 8. There is a unique specialty for these numbers. Okay, and the property of this is a perfect square square's last digit cannot be 2, 3, 7, or 8. It could be any other number. It could be any other number, but a perfect square's last digit cannot be 2, 3, 7, or 8. A perfect square's last digit can be 1, 4, 5, 6, 9, 0. It all are possible. But if the number ends in 2, 3, 7, or 8, you can straight away say it's not a perfect square. Clear, people? Excellent. Now getting back to the question here. Okay, I don't know how many of you guys remember this question, but still, here's the question here. Find the rightmost non-zero integer of the expression 1430 power 343 plus 1470 power 367. So that's the question. Now, if you look at this question, let's take this one 1430 power 343. First of all, let's write this number. Okay, obviously it's going to be a very big number. I cannot write the entire value, but still, let's write the rightmost part. How many zeros will I have here? How many zeros will I have here? In this value 1430 power 343, just that part. How many zeros will be there? Very good. 343 zeros will definitely be there. So 1, 2, 3, 4, 5, 6. It goes on. There'll be a lot of zeros, which is actually there will be 343 zeros. Okay, and then I'll have a digit. What will be that digit? 3 power 343. So 3 power 343. Can you guys tell me what will be the last digit of this one? Because 0, instead of 0, I've written 343 zeros. So take that away. So 3 power 343. What will be the last digit of 3 power 343? Because I know 3971. Remainder 1, remainder 2, remainder 3, and remainder 0. Correct? Can you guys tell me what will be the last digit here? Very good, Sham. Because we have got 343. If I divide this power value 343 by 4, if I divide 343 by 4, the remainder is 3. If the remainder is 3, then my last digit is 7. So the last digit is 7. Okay, excellent. Now let's take the second part. 1470 power 367. So 1470 power 367. Excellent. Now, In this particular value alone, how many zeros will be there? How many zeros would I have at the end? Just at the end, how many zeros would I have? Very good, super. Correct, Harivartini. So definitely there'll be 367 zeros. So there'll definitely be more zeros than the previous number. Okay, this is an, let's say, imaginary line. I'm drawing imaginary line here. Let's say this line corresponds to 343 zeros. I'll definitely have more zeros than that. I'll definitely have more zeros than that. And here is where the first number would be. What would be the first number here? 7 power 367. I don't even have to find that out because they have asked me to add these two numbers. If I add these two numbers, what would happen, guys? In all these places, it would just be 0, 0, 0, 0, 0, 0, 0, and 0. Correct? It would just be 0 here. But here it would be 7 plus 0, 7. So in the final answer, if I look at the rightmost non-zero integer, it would be 7. Are you guys clear with this one? Please tell me if you guys are clear with this question. Yes. Okay, guys, fine then. We'll move on to the next questions now. The next thing that we are going to look at is factors. Okay. Sir, what do we mean by factors, sir? I know how to find out factors and all that. Okay, fine. Then, can you guys tell me how many factors are there for the number 6? How many factors does the number 6 have? The number 6 has how many factors? That's my question, guys. Yeah, I'm sorry, guys. Hope now I'm audible. Everyone? Students, am I audible? Yes, excellent. Now we were discussing about the factors. Let's take the number 6. How many factors are there? There are 4 factors. Obviously, yes. What are the factors? 1, 2, 3, and 6. Excellent. There are 4 factors. Super. Now let's say Let's take the numbers 24. Can you guys tell me what are the factors here? Let's list out one after the other. What are the factors of 24? What are the factors of 24, guys? Very good, super. So 1, 2, 3, 4, 6, 8, 12, and then 24. Correct. So how many factors does it have? So it has 6 4s are 24, 8 3s are 24, 12 2s are 24, and 24 into 1, 24. So totally there are 8 factors. Correct. Now for any number, it is easy to find out the factors and count the number of factors, right? So if I tell you, if I ask you guys, okay, if I give you guys a number, you can easily find out the number of factors, is it not? Yes. Okay. Can you guys find out the number of factors of 3600? Can we do this by the normal method? It will obviously take a lot of time, right? So you'll have to start with 1. Yes, 1 is a factor, 2 is a factor, 3 is a factor, 4, 5, and then you have to check for 6. 7, no, it is not divisible by 7. Go for all of the numbers. So practically it's impossible. Or else it will take a lot of time. So that's what I mean. Correct. So we need another method to find out the number of factors. Correct. So that is what we are going to discuss right now. Method to find out number of factors. I'm going to take the number 24 as an example because we already know how many factors are there. So there are 8 factors, right? Let's take the same number 24. And the first step that I want you guys to do is write 24 in terms of prime numbers. How do I write 24 in terms of prime numbers, sir? The prime factorization. And this is not a difficult concept. We have already seen this. What is prime factorization? Normal L division, guys. That's all. So 24. If I divide it upon 2, I'll have 12. If I divide it upon 2, again I'll have 6. If I again divide it upon 2, I'll have 3. And if I divide it upon 3, I'll have 1 at the end. Correct? Clear, people? Okay. So how can I represent this 24? So I can write this as 2 cube into 3 power 1. So because 2 cube, 3 power 1. That's all. Once you write them in terms of prime numbers, see, you should only divide by using 2, 3, 5. So like prime numbers, you can only divide using prime numbers. You cannot divide it by 4. Yes, it is divisible by 4, but you should not use 4 because this concept is prime factorization. So writing the number in terms of prime numbers. So after doing that, take the power value, add 1 to it. So 3 plus 1, 4. 1 plus 1, 2. So 4 2s are 8. So there are 8 factors. Clear, people? Yes. So this is how you can find out the number of factors easily. So this is how you can find out the number of factors easily. Similarly, try to find out the number of factors for the number 3600. Try to find out the number of factors for the number 3600. Very good, Giridharan. Super. Because for 3600, okay, if you are clever enough, you don't even need this L division. I can straight away write 3600 as 36 into 100. So 36, I can write it as 9 into 4. So 100, I can write it as 4 into 25. Correct? So this is 3 square into 2 square into 2 square into 5 square. So my answer is 2 power 4 into 3 square into 5 square. So take the power value, add 1 to it. So 5 square, right? I'm sorry. 5 square. Excellent. Now take the power value and add 1 to it. So 4 plus 1, 5. 2 plus 1, 3. 2 plus 1, 3. So 5, 3, 3. Multiply them, you get 45 factors. Are you all clear with this concept, guys? Please tell me if you guys are clear. Everyone? Yes. Super. But listen carefully. Uh, Now I'm going to make this question a bit more tedious. Okay, so this is how we, okay, first I'll explain to you the question that I'm talking about. The question that I'm asking you is, in how many ways can I write 24 as a product of two numbers? As a product of two numbers. Okay, can you guys tell me in how many ways can I write 24 as a product of two numbers? Sir, what do you mean by that, sir? Okay, 24. Can I write it as 1 into 24? That is one possibility. Can I write it as 2 into 12? Yes. Similarly, in how many ways can I write 24 as a product of two numbers? Is it 8 or 4? Think carefully. Guys, 1 into 24 and 24 into 1 are not two different concepts. It's again the same only. 1 into 24 or 24 into 1, both are same. So 1 into 24, 2 into 12, 3 into 8, 4 into, sorry, 3 into 8, 4 into 6. So there are 4 ways in which I can write that. Yes. Correct. But how many factors were there? 8 factors. 8 factors. So what were those factors? 1, 24, 2, 12, 3, 8, and 4, 6. So once you find out the number of factors, it is easy to find out the number of ways in which you can write that particular number as a product of two numbers. Clear, people? How do I find out? Number of factors divided by 2, you'll get the answer. Number of factors divided by 2, you'll get the answer. Clear? Now, if I give you a number, can you guys tell me the number of ways in which you can find out write the numbers as a product of two numbers? Can you do it? Yes or no? Guys, tell me if you guys are ready, and then I'll tell you. I'm going to give you guys a number, and you should tell me the number of ways in which I can write that particular number as a product of two numbers. Okay. And let me tell you one more thing. The question that I'm going to ask you guys right now, it was actually a TCS star question. So earlier TCS used to have different sets of questions. So one such questions was what was called as star question, which means other questions used to carry 1 mark, whereas the star question used to carry 2 marks, because they considered that this is a difficult question. So if you are able to do it, you'll get 2 marks for it. So this was a TCS star question. Okay. The question is, in how many ways can I write 3600 as a product of two numbers? In how many ways can I write 3600 as a product of two numbers? Okay. Let me tell you what is the problem here. Listen carefully. The method is again the same. The number of factors divided by 2, which means 45 by 2. It is actually 22.5. But can the number of ways be in decimal point view? No. The number of ways cannot be decimal. Then what do I do, sir? So the number of ways is it 22 ways or 23 ways? How do I take it? To understand that clearly, let's take another smaller number which has odd number of factors. For example, let's take the number 4. What are the factors of the number 4, guys? What are the factors of the number 4? It's a simple question. What are the factors of the number 4? Very good, Radha. So it is 1, 2, and 4, which means there are 3 factors. But in how many ways can I write 4 as a product of 2 numbers? I can write it as 1 into 4 or else 2 into 2 also. So 2 ways. Correct. But if I divide it by 2, I'll have 1.5. So this 0.5 is also considered as 1. So 1 plus 1, 2 ways. Sir, why am I getting odd number of factors? So here is the fact. Remember, perfect squares will have odd number of factors. Perfect squares will have odd number of factors. Is that clear? Take any perfect square. Take 9, 1, 3, 9. 3 factors, odd number. Take the number 16. What are the factors of the number 16? 1, 2, 4, 8, 16. So 5 factors. Again, odd number. Now using this logic, tell me what is the answer for the actual question? In how many ways can I write 3600 as a product of 2 numbers, guys? In how many ways can I write 3600 as a product of 2 numbers? Is it 22 or 23? Very good, Deepthi. Superb. The answer is 23 ways. This was a TCS star question. Okay, but a few years back, not now, a few years back. Fine then. Moving on to the next ones. Now it's a simple question. What is the LCM of 6 and 10? It's a simple question. What is the LCM of 6 and 10? Very good, guys. Superb. Very good, Lokesh, Radha, Vishnu, and Deepthi. And I'm seriously surprised. See, my question was a simple question. What was my question? I asked you guys to find out the LCM of these 2 numbers. That's all. But the problem that we face, a lot of us face, is we don't understand what this particular LCM means. We all know LCM means least common multiple. Okay, we remember that very clearly. But what does that actually mean? Least common multiple. Okay, let's say, for example, let me take the number 10 and 15. First, let's start writing the numbers which are multiples of 10. What are the numbers which are multiples of 10? What do you mean by multiples of 10, guys? Can you guys tell me what do I mean by multiples of 10? What are the multiples of 10? Okay, listen. So 10, 20, 30, 40, 50, 60, 70, 80, 90, goes on like this. So these are the multiples of 10. What are the multiples of 15? 15, 30, 45, 60, 75, 90, 105, goes on like this. So I've written the multiples. Okay, can you guys tell me what are the common multiples here? 30 is common, 60 is common, 90 is common. Similarly, 120 will be common, 150, 180, all these things will be common. Okay, fine. So I have found out the common multiples also. Out of that, which one is the least? 30 is the least. So LCM is 30. Clear, people? So that is what it actually means. That is what it actually means. Very good. Correct. Similarly, when I say HCF, highest common factor. Okay, what are the factors of 10? Okay, let's take 10 and 15. First, let me start writing the factors. What are the factors of 10, guys? What are the factors of 10? Very good. 1, 2, 5, 10. What are the factors of 15? 1, 3, 5, 15. Okay. So once you are done with finding out the factors, find out the common factors. What are the common factors here? 1 is common and then 5 is common. Okay. Done. So once that is done, common factor is also found out. Now, out of the common, which one is the highest? 5. So HCF is 5. Clear, people? So this is what the LCM and HCF term means. The term LCM, it means least common multiple. Out of the multiples, find out which one is common. Out of that, which one is the least. So that is what they call it as least common multiple. Okay. Now, how do we find out LCM? Let's say, for example, they are asking us to find out LCM of 6 and 10. There are multiple ways to find out LCM. Okay. So let's say, for example, the simplest one, or the ones that has been taught to us so far, going with the L division. 2 table, 3, 5. So no common multiples, but still, if you want to be clear, 1 and 5. 5, 1 and 1. So multiply these 3. 2, 3, 6, 5, 6 are 30. So LCM is 30. So this is what was taught to us so far. But what I would suggest is go with the second method. Let's say 6 and 10. You are supposed to find out the LCM of 6 and 10. Take the bigger number. Which one is the bigger number? 10. Write the multiples of it. Start writing the multiples of it and check which multiple is divisible by 6 also. 10 by 6, no. 20 by 6, no. 30 by 6, yes. Then that is your LCM. Is that clear, people? So in this method, you can find out a lot of LCMs easily. For example, if I want to find out 10 and 12's LCM, so write down the multiples of 12. 12, 24 by 10, no. 36 by 10, 48 by 10, no. 60 by 10, yes. So 60 is the LCM. Clear, people, with this method? Are you guys clear with this method now? Guys, please tell me if you guys are clear. Yes, excellent then. Now there is one more method also. I'll also teach you guys that method. Say for example, I'm supposed to find out 6 and 10's LCM, right? Okay, this is the third method, 6 and 10's LCM. Write down the simplest form of writing 6 by 10. How do I write 6 by 10 in the simplest possible way? So common, I can cancel out 2. So if I cancel 2 out, I'll have 3 by 5. So there is no other simple way of writing the ratio of these two. Okay, so once that is done, multiply the cross multiply. 6 into 5 also 30, 10 into 3 is also 30. So either way, you'll get the LCM. 30. Clear, people? Let's say, for example, if you want to find out the LCM of 10 and 15. Okay. So what is the simplest way of writing it? 2 by 3. So it is 30 or else 30. Either way, it's 30. So LCM of 10 and 12. How do I write it in the simplest format? If I cancel it in terms of 2, 5 by 6. 60 or else 60. Clear, people? But listen carefully. Sometimes what happens, they might ask you questions in a different way. For example, they ask you a question that says, okay, so what is the least number which, when divided by 6 and 10, leaves the remainder 3 in each case? Which means they're asking us to find out a number. If I divide it by 6 also, the remainder should be 3. If I divide this particular number by 10 also, then the remainder should be 3. That is what they're asking us to find out. Okay. First tell me, if I take the LCM of 6 and 10 and divide that particular LCM by 6 or 10, what will be the remainder, guys? LCM of 6 and 10 divided by 6, what will be the remainder? LCM of 6 and 10, and I'm dividing the LCM by 6. What will be the remainder, guys? Very good, Harivarshini. It will be 0 because the LCM will definitely be divisible by those numbers. That is the reason why we call it as LCM, right? That's a common multiple. So definitely it will be divisible. Yes. Same LCM. If I divide it by 10, the remainder would be 0, correct? So for us to get remainder 3, add 3 to the LCM, that's all. LCM of 6 and 10 plus 3. What is the LCM of 6 and 10? 30. 30 plus 3, 33. If you want, if required, you can also check it. 33 by 6, 30 is divisible, remainder is 3. 33 by 10, 30 is divisible, remainder is 3. Clear, people? Are you guys clear? Can we move on to the next question? Yes, excellent. Okay. Can you please answer this question now? It's a simple question now. Come on, guys, what is the answer here? Find the number which, when divided by 12, 8, and 10, leaves the same remainder 7 in each case. Very good, Harivardhani. Superb. Excellent, guys. Excellent, rather. So, what did I tell you? First, take the LCM of these numbers. LCM of 12, 8, and 10. And then add 7 to it because same remainder in each case. So add 7 to it. What is the LCM of these three numbers? 120. So add 7 to it. So it is 127. So my answer is 127. So this is one way of solving this question. But if you are a practical thinker, what are they asking us to find out? A number, if I divide it by 12, the remainder is 7. A number, if I divide it by 8 also, the remainder is 7. A number, if I divide it by 10 also, the remainder is 7. So this is the important part. The last part is the important part. Out of the option, which number when divided by 10 gives me the remainder 7? If I divide this number by 10, what is the remainder, guys? Remainder would be 8. The last digit would be the remainder. Here the remainder would be 9. Here the remainder would be 6. This is the only option that gives you the remainder 7 when divided by 10. Okay, so that is the practical approach using options. But you should also know how to find out 127. Clear, people? Now, this was an easy question. But let's say you have a question of this sort. Find the least number which when divided by the number which when divided by 12, 8 and 10 leaves different reminders. Here the remainder should be 10. In this case, the remainder should be 6. In this case, the remainder should be 8. Okay, so again, if you think logically, using this itself, you can find out the answer. Using this logic itself, you can find out the answer. Can you please tell me what is the answer using that logic itself? A number which when divided by 10 should leave the remainder 8. Which one gives us 8 as the remainder when divided by 10? Very good, Radha, Darshan, Shyam and Nitish. So definitely the answer is 118. That's fine. But sir, how do I actually find out the answer? See, here in this case, I cannot add, let's say, for example, I cannot go with LCM of 12, 8 and 10 and then add that particular remainder. I cannot do that because the remainder is not same. It is different in different case. Or else it actually just looks different, but it is not different at all. So it is different. So 10 is different from 6. 6 is different from 8. How are you telling me it may not seem different? Let me tell you this way. Listen, the numbers are not selected randomly, not given randomly. 10, it's actually its corresponding divisor minus 2. Correct? It's divisor minus 2, 12 minus 2. 6 is actually divisor minus 2, 8 minus 2. 8 is actually its corresponding divisor 10 minus 2. Okay, so all you're supposed to do is find out the LCM, subtract 2 from it, not add 2, subtract 2 from it. What's the LCM of 6? Sorry, 8, 10 and 12? 120 minus 2. So my answer is 118. Clear, people? Are you all clear with this one? Shall we move on to the next question now? Excellently, super. Now here's my next question. Find out the remainder when 3 power 75 is divided by 5. Okay. Now listen carefully. 3 power 75 is divided by 5. I'm supposed to find out the remainder. Okay. I'm going to give you guys a minute, but you can solve this question just by the concepts that we have seen so far. But all that requires for this particular question is a bit of logical sense. If you think logically, you can solve this question. I'll give you guys a minute, think, and then we'll discuss. No idea. Okay, guys. Now listen here. We obviously know the method to find out the last digit of 3 power 75, right? Can you guys tell me what would be the last digit of 3 power 75? What would be the last digit of? No, think carefully. What would be the last digit? I'm not asking you to find out the remainder. What would be the last digit of 3 power 75? Will it be 3, guys? 3 power 75. Take the power value divided by 4. The remainder is 3. Then what is the last digit? 7. Very good, Harivardhani. Guys, forgot the last digit of 3. Huh? What happens for 3? 3, 9, 7, 1. If the remainder is 1, then this is my answer. The remainder is 2, then this is my last digit. The remainder is 3, then this is my last digit. The remainder is 0, then this is my last digit. Okay, so 75. So 75 by 4. What is the remainder, guys? 72 is divisible. So the remainder is 3. The remainder is 3, then the last digit is 7. So this is actually a very big number, but the last digit is 7. Okay, so this is a very big number and the last digit is 7. And I'm dividing that particular number by 5. Can you guys tell me what will be the remainder? Take any number that ends in 7 and divide it by 5 and tell me what will be the remainder. Very good, Harivardhani. Superb. Take any number, guys. Even if you take 7, 7 by 5, what is the remainder? 2. Because 5 is divisible. Take 17. 7 by 5. What is the remainder? 2. Take 17 by 5. What is the remainder? 2. Let's say 1, 2, 3, 4, 5, 6, 7 by 5. What will be the remainder? It will definitely be 2 because 1, 2, 3, 4, 5, 6, 5 will be divisible and then 2 will not be divisible. So that is the remainder. So my answer is 2. Are you guys clear with this question, everyone? Shall we move on to the next question now? Are you guys ready? Tell me if you guys are ready. Come on fast. We'll move on to the next one. Okay, fine then. We'll move on to the next question now. Here's our next question. Okay, now this is an excellent question. If both 11 square and 3 cube are factors of the number a into 4 cube into 6 power 6 into 13 power 11, then what is the smallest possible value of a? Then what is the smallest possible value of a? Okay, so before getting to this concept, I'm going to ask you guys two simple questions. Listen carefully. A into 3 is a number. It's a single number. A into 3 is a single number. And I am telling you that this number is divisible by 2. This number is divisible by 2. Can you guys tell me what are the possibilities for the value of a? What could be the value of a? What could be the value of a? I'm not asking you what is the value of a because there are multiple possibilities. But what is the question that I've given you? A into 3 is a single number and it is divisible by 2. Very good, Harivardhani. So 3 is not divisible by 2, right? I'm telling you it is divisible. It is divisible. Yes. And I know 3 is not divisible by 2. So a should be divisible by 2. So what are the possibility of a? It could be 2, 4, 6, 8 or anything. But if I tell you, if I ask you to find out what is the, yes, very good, Nitya Kalyan. If I ask you to find out what is the smallest possibility of a, what is the smallest possible number of a, value of a? What is the smallest possible value of a? Very good, 2. Because out of all the possibilities 2, 4, 6, 8, 10, 12, 14, 16, 18, What is the smallest possibility? 2. Correct? Excellent. Now, same way, if I tell you B into 3 is divisible by 3, is divisible by 3. Okay. Can you guys tell me what are the possibilities of B, guys? What is the possibility for B? I'm telling you B into 3 should be divisible by 3. What are the possibilities of B? Very good. Excellent, Arivardhini. There is no condition at all now because I already have a number 3 which is divisible by 3. So the value of B can be any number. There is no condition that it should be an odd number or even number. Even if you take 1 into 3 is 3, divisible by 3. Even if you take even number 2 for the value of B, 2 into 3 is 6. 6 is divisible by 3. Clear, people? There is no condition now because I already have a number which is divisible by 3. So in that case, B can be any number. Any number. Okay, minimum possibility is 1. Minimum possibility for B is 1. Clear with these two conditions so far? Clear, everyone? Guys, tell me if you guys are clear with these two conditions.
Yes, sir.
Okay. Now listen here. Now this is my actual question. If both these numbers are factors of these numbers, what do you mean by factors? If A is a factor of B, then B by A should be divisible. For example, if we take 6, what are the factors of 6? 1, 2, 3, and 6. So 6 by 1 should be divisible. 6 by 2 should be divisible. 6 by 3 should be divisible. 6 by 6 should be divisible. Similarly, they are telling us A into 4 cube into 6 power 6 into 13 power 11. For this particular number, 11 square is a factor, and at the same time, for the same number, A into 4 cube into 6 power 6 into 13 power 11, 3 cube is also a factor. Okay. First tell me, I don't know about A. Let's look at the other part. Just look at the part that I've underlined in red. Is this part divisible by 11 or not? Okay, is this part divisible by 11 square? Can I divide that other part by 11 square? Is it possible? Can I do that? Tell me, guys. Is it possible to do that? Can I divide the right side part by 11 square? 4 cube, definitely it is not divisible by 11 because 4 is a different prime factor because that's actually 2 power 6. 4 is actually 2 square, the whole power cube. So it is 2 power 6. So don't worry about that. 6 power 6, it contains only 2 and 3. 6 is 2 and 3, made of 2 and 3. I don't have 11 at all there. Very good, Diti. If I look at 13, 13 is a different prime number, 11 is a different prime number. Definitely it will not be divisible. So definitely A should be divisible by 11 square. A should be divisible by 11 square. Yes. Now, can you guys tell me what is the minimum possibility of A? The minimum possibility of A, it should be 11 square at least. It could be 11 square, which is 121 or else 242. There are multiple possibilities. Okay, but minimum possibility is it should be 11 square, which is 121. Here, according to the first case. Okay, because minimum it should be 11 square. It could be 11 square into 2. It could be 11 power 395. I don't care. Minimum it should be 11 square. And if you look at the second case, if you look at the right side part alone, forget about A. If you look at the right side part alone, is this part divisible by 3 cube? Think carefully and tell me, is this part divisible by 3 cube? Very good, Harivardhani. Yes, definitely is divisible. How is that divisible, sir? Because 6 power 6, it actually has 2 power 6 into 3 power 6. So 3 power 6 and 3 cube can easily be divisible. So A could be any number. According to this case, A could be any number. It could be 1, 2, 3, 4 or any number. But here I have a condition. It should be minimum of 121. So my answer is should be a minimum. Smallest possibility is 121. Clear with this question, everyone? Are you guys clear, everyone? Guys, I think it's time, right? So the session ends by 2:15. Yes. Okay, no issues. I'll be here for a couple of more minutes. If you guys have any doubts, you guys can ask me right now, or else we can end this session. If any doubts, you guys can ask me right now. Yes. No doubts. Okay, guys. If you don't have any doubts, you can leave the session. Okay, guys. Fine, then you're welcome. Okay, guys, go for a small break. I think your next session starts by 2:30, right? Okay, please do make sure you guys are there on time. Actually, in time. Okay. Bye, guys.
Thank you, sir.
Okay.